Hi students, I am KNK of Physics Department from Kakinada branch. So here is the solutions for the paper on 10th August. So here is the first question, that is question number 21. So here is asking the charge that flows through the coil. So that can be written as I is equal to delta phi by R. Okay, here the coil was rotated through 180 degrees, so that actually phi is equal to VA cos theta. So here delta phi means we have to take the phi 2 minus phi 1. By taking VA as a common factor, then you will get cos 180 minus cos 0. Then by taking the magnitude, then you will get 2 VA. So that can be written as 2 phi. So that I can be written as 2 phi by R. So that is the answer for the first question. Next, question number 22 here. So for the question number 22 here, a short bar magnet is fall into the ring. So here it is the ring and here it is the short bar magnet which is falling. So here we have to find out the distance of each. So here what is the formula? D is equal to ut plus half at square. So it is falling from rest, so that is why I am taking as half gt square. So what is g here? G means 10, t square means 1 only. So that is half, you will get 5 only. But here according to this, so acceleration should always less than the top the g, that is acceleration due to gravity. So the value is less than the top 10. So d is less than the top 5 only. So from the given options, so only the option 1 is having the less value. So 4 is less than the top 5. So that is the answer here. Next, question number 23 here. Question number 23. So according to this one, so we have to find out the average EMF. So average EMF means so E is equal to delta phi divided by T. So delta phi by delta T. Okay. So according to this given question, given the value of flux, that is 500 mu, that is a microweber, and the number of turns 200, and here also the coil was reversed. So you have to take 2 into n into delta phi. So 2 into n into phi divided by delta T. That is the formula. Where n is number of turns. So that is equal to 2 into number of turns 200, that into 500 into 10 power minus 6. That divided by what is the value of time? Time is 20 into 10 power minus 3 seconds. 20 into 10 power minus 3 seconds. By simplification of this will 10 times, that is 200. You will get a 10 volts. Okay. Next, question number 24. So according to the question number 24, a square coil of movable size. So here initially this is the coil. So each having the 0.05 meters. All these sides are movable sides. So here he has moved with a velocity v is equal to 0.1 meter per second. In a time t is equal to 4 seconds. So now what is the next change? After motion, so this side is like this and this side is up to this side is up to this like that. So what is the resultant figure? This is the resultant figure. Okay. So here we will draw it in the next page. So tan 8. So here, so this is the present figure after the motion. So this is the initial figure before motion. Okay. So this is the 0.5. So this one and this one are same. So the distance is can be find out d is equal to velocity into time, that is equal to 0.4 according to the given parameters. So what is the total length? Now the total length can be written as 0.5 plus 0.4 plus this is of 0.4, that is 1.3 only. What is the change in the area? Initial area A1, final area A2. So what is change in that one? Delta A can be written as A2 minus A1. A2 means this is 1.69 minus A1 means that is 0.25, then you will get 1.44 meters square. That is the change in area. According to the given problem, here, so we have to find out the EMF. So that EMF E can be written as E is equal to B delta A divided by delta T. So what is B here? So B means 0.2. 0.2 into A means 1.44 divided by what is delta T? Delta T means in 4 seconds, no? So that is a 4. So by simplification of this you will get 0.072 volts. That is the answer. Next students, question number 25. So here question number 25. In this question two rings are moving of same plane. So this is moving in this direction, this is moving in this direction. So the field is in this direction. So by the application of Fleming's right hand rule. So right hand rule. So this is the direction. Okay. In which direction? The central finger is showing in upward direction, so that higher potential is at this point. So I am taking these 2 points as 1 and 2, these 2 points are 3 and 4. Okay, so being these 2 points are of the same plane, so those are nothing but equipotential surfaces. So we can write V1 is equal to V3. So from this ring you can write the value of the V2 minus V1. Why means 2 is the higher potential according to the Fleming's right hand rule. So E into what is the effective length between these two? If R is the radius, then the effective length can be written as 2R into V. That is equal to 2R EV. Sorry, 2R BV. Sorry, that is BV. Okay, next, what is this? So here 3 is at a higher potential. So V3 minus V4 is equal to, again the same thing you will get 2R BV only. Now what is the total value? So by adding these two, so V2 minus V1 plus V3 minus V4, this is 2R BV, that will gives you 4R BV. So here V1 and V2 are equal now, so these get cancelled here. So V2 minus V4 is equal to 4R BV. So that is option 3 is the right answer. So next, question number 26. Here, so given the value phi is equal to 60 square minus 5t plus 1, that is the value. So what is the E value? E is equal to d phi by dt. So that is equal to, this is of 12t minus 5. That is by application of differentiation. So that E at t is equal to 1 by 4 seconds. That is equal to 12 into 1 by 4 minus 5. That is equal to, this is of 3 minus 2, that is minus 2. We have to find out the magnitude of current. So I is equal to E by R. E means 2 by R means 2, that is equal to 0.2 ampere. Next, question number 27. So in question number 27, so here also the coil was turned to 180 degrees. So the charge passing through the coil is, here also we have to find out the charge. So what is the formula for the charge? Q is equal to delta phi by R, that is the formula for the charge. So that here the coil was turned through 180 degrees, so that the delta phi can be written as 2, that is 2 NVA by R. So delta phi means 2 into 5, so 2 into BA. But here we are having n number of turns, that is the answer. So 2n BA by R is the right answer, that is option 4 is the right answer. Next, here it is the question number 28. In this question number 28, a square loop was turned into circle. So this is the square loop. So this is the square and this was turned into circle. So first of all we have to find out the radius of the circle. This is one is having 22 centimeters is the side. So we have to find out the radius. So to have that one we have to equal the perimeters of those two structures. So here 2 into 2 pi r, 2 into 27 by 2 for this, that is r is equal to, all sides are 88. So I am taking 22 into 4, that is 88 in centimeters. So this is of 4 times now. So R is equal to 14 centimeters square. R is equal to 14 centimeters. Now, what is the change in the area that we have to find out? So, change in area A2 minus A1, that is for the area of this thing. So, by taking common in those two parameters, so initially I am writing those two, 22 by 7 into R square. R square means 14 into 14 minus, what is this? So, the area of this, that is 22 into 22. So, 22 into 22. What is 22 into 22? By taking the common factors, you will get, so 3 into 44 into 10 power minus 4 meter square. That is the change in the area. That is the change in the area. So now here in this problem you have to find out the induced EMF. So according to this induced EMF means E is equal to B into delta A by delta T. So B into delta A by delta T. So what is B here? B means 0.2 Tesla. So 0.2 Tesla into delta A means here 3 into 44 into 10 power minus 4 divided by what is delta T? In a time 0.4 seconds. So that is 0.4 seconds. Here you have minus sign here. So minus into, by simplification of this you will get 6.6 millivolts. So that is the answer for the question 28. Next, question number 29. So here question number 29. A circular coil of bar magnet placed nearby me. So nearby me. This is the circular coil, this is the bar magnet. So both are moving in the same direction. So what is the velocity of this? Velocity is equal to, so distance by time. So the distance traveled in 1 meter in 0.5 seconds. So 1 meter by 0.5, this is 2 meter per second. So for this also, what is the velocity? 2 meters in 1 second. This is also having 2 meters per second velocity. So both are moving with the same velocity. What is the relative velocity? Relative velocity is equal to 0. If the relative velocity is equal to 0, then there is no change in the flux. If both are moving with the same direction. So that induced EMF is equal to 0. So that current is also equal to 0. That is question number 29. Next, question number 30. What is question number 30? Here it is. A square plate, here L meters of the square plate which is lies in XY plane. So that L bar can be written as L into K. L into K. So what is the area vector? A bar can be written as L square K. L square K. And what is B here? B bar is equal to B naught into B naught of, so 2y plus 3j. 2y plus 3j plus 4k. So here we have to find out the flux, that is dot product between the magnetic field vector and area vector. So A bar, that is equal to, here only k component should be multiplied here. So B naught 4k into L square. So B naught 4k L, sorry, B naught 4 L square. So that is equal to 4 B naught L square Weber. So that is the answer. So option 3 is the right answer. So thank you students.